Here we go. Okay, item number one is just a review of graphing quadratics. So you need to be familiar with a couple models. This one right here is going to be Vertex Model. Okay, the vertex form of a quadratic, the general equation looks like this. Y equals ax minus h squared plus k. And how you know you're going to use the vertex form is this right here. They give you the vertex. So if you look at this quadratic and the vertex happens to land on whole numbers, and then use the vertex model. So that vertex is over 4 and down 1. So that right there is my vertex. My vertex is going to be there and there. So I'm going to plug 4 in place of h and a -1 in place of k. So here we go. Step number 2. Y equals a. It's x minus h. So it's going to be x minus whatever h is. H is 4 squared and k is a -1. So it's going to look like this. Okay, now remember, this is the tricky one right here. The number inside the parentheses before you square it. That tells you to move left or right. That's your horizontal shift. And -4 means you are going 4 to the right. If it was a +4, that would mean you're going to go 4 to the left. So since my vertex is 4 to the right, make sure you get the sign right. So it's actually going to be a -4, and then this one is, there's no trickiness to it. -1 means go down 1. This is your up or down. Okay, now all you need to find is the value of a, and here's what you should know. A is going to be some negative number because my graph is concave down, and a determines how wide or skinny it is. So to find the value of a, you need to pick another point on this graph. You have a couple to choose from. It does not matter which point you pick. So if I pick this one right here, you got to pick a point that's on 2 numbers, just like your vertex was. You cannot pick this point right here because it's on some fractions. It's in between 2 numbers. It's in between a -6 and a -7. So it might be like -6.2, who knows. So this dot right here, I'm going to go over 3 and then down 4. And that represents this dot. So now I'm going to take this 3 and this -4, and I'm going to substitute them in place of x and y. And so I'm going to take this 3 and I'm going to plug it in for the x. I'm going to take this -4, plug it in for the y, and then do the math. And I have everything except for a. So if I plug those 2 numbers in and do the math, it should give me a. So in place of y, I'm going to put a -4. In place of x, I'm going to put 3 minus 4 squared. Okay, do the parentheses first. 3 take away 4 is a -1. A -1, exponents next. -1 times a -1 is a +1. So I got a -4 equals a times 1 minus 1. Okay, now this 1 is multiplying the a. So you cannot combine it with the -1. Do not add these two together. This should be rewritten as a -4 equals 1a minus 1. Okay, now solve for a. +1 plus 1. -3 is equal to a. So now you are completely done, and your final answer is going to be y equals a -3 x minus 4 squared minus 1. Okay, number 2, this is going to test our other model. So it's a quadratic. They give you the picture, you write the graph. This one, the vertex right here, happens to be on some fraction, and I don't even know where that is. But I do know the roots. So I'm going to use the factored model. Okay, the factored model is y equals a, x plus or minus some roots, and x plus or minus some root. Okay, I'm going to make a table and I'm going to plot these 2 points right here, my roots. This point is over 2 and 0, and this point right here is -1 and 0. Okay, these are my 2 roots. So I am now going to plug these roots in to the model. But it's kind of tricky. Y equals a x x. The trick is the sign. Is it going to be a positive or is it going to be negative? So the 2, is it a +2 or is it a -2? Okay, now 0 is the y. So you gotta ask yourself, if you put 0 in for y, 0 equals a, and in place of x you put the 2, and you want your answer to be 0, I know the sign must be minus. This has to be -2, because a 2 minus a 2 is a 0, and we're trying to get zeros, because 0 times any of this stuff is going to be 0. So their sign has to be minus, which is kind of opposite what it is on the table and in the graph. So this next root, this -1, 0, this dot right here, -1, 0, is actually going to be x plus 1. Because if I put 0 for y, and I put -1 in right here for x, so this x right here, I'm replacing with a -1, -1 plus 1, that is a 0. 0 times this is 0. So this is what we've got right here, and if you mess up, you're going to mess up on the signs. Do not mess up on those signs. Okay, A, you know A has to be positive, it's concave up, and you find A the exact same way. Look at your graph, find another dot. I'm going to use this dot right here. Okay, this dot, I go over 1 and down 2, over 1, down 2. Okay, I'm going to plug this in for my x and this in for my y. So my y, right here, I'm going to replace with a -2. Keep A, replace x with 1. Replace this x with 1. Okay, now let's do some math. -2 is equal to a times 1 minus 2 is a -1. 1 plus 1 is 2. Okay, a times a -1 times 2, that's all times problem, so it's going to be -2 equals -2a. Okay, now undo the -2 by dividing. Divide by -2, divide by -2, so a is actually equal to a +1. So if a is equal to 1, my answer is y equals 1. I don't even need to write the 1. X minus 2, x plus 1. Okay, the vertex of the graph. Now this is not the vertex form, and it's not factored form. This is standard form. So the third model is standard. Standard is y equals ax squared plus bx plus c. And when it's in standard form, to find the vertex, it's not too bad. Remember this right here, c, that's your y-intercept. So if you're going to graph this, 3 is going to be your very first dot. You're going to come up here and put a dot on 3, and then your next move when it's in standard is to find your line of symmetry. And our vertex is going to be right here. Okay, the line of symmetry, you've got to memorize, it's a -b divided by 2a. So it is going to be a -8 divided by 2 times a. So it's going to be a -8 divided by 4, which is going to be a -2. So your line of symmetry is going to be at -2. And at this point I can stop and choose D, because that's the only x that's -2. But if you want to prove that the y is -5, that's not too bad. So you're going to take this -2 for x, and if you know what the x is but you do not know what the y is, you just take this and you plug it in to your function for both the x's, do the math, and it will give you -5. So 2 times negative 2 squared plus 8 times negative 2 plus 3. Alright, exponents first. Negative 2 times negative 2 is 4. 4 times 2 is 8. 8 times negative 2 is negative 16. And then plus 3, so 8 plus negative 16 is a negative 8. Negative 8 plus 3 is negative 5. So that is the vertex. Okay, which function could be describing this one? And A, B, C, and D are all vertex form. So that makes it easy. The vertex is going to be left and up. So over to the left and up. So I know this model looks like this. Okay, I know A has to be a negative, some kind of a negative number. So first I look at all my A's. A is the number in front. And the only ones that satisfy are going to be C and D. So I can eliminate A and B. Now look at C. C is x minus 5 in parentheses. So if I draw a picture of C real quick, minus 5, does that tell you to go left 5 or right 5? And it tells you to actually go right 5. And then minus 3 is down 3. So your vertex is right there. So it is not C. D, let's check D. Plus 5 means go left 5. Go left 5 up 3. Yep, that could be D. Okay, another function in standard form. Is it concave up or down? It's going to be up because A is positive. The y-intercept, that is negative 6. The y-intercept is C. The axis of symmetry, we just did this. Negative b divided by 2a. So it's going to be negative 12 divided by 2 times 3. Negative 12 divided by 6, negative 2. So it's over here. It's actually, the equation is x equals negative 2. So on the x-axis, come over negative 2, and you're going to have a vertical line right there. Okay, now to find the vertex, you have to take that negative 2, and if you want to find the y, how far up or down to go, you got to take it and you got to plug it into the function. So it's going to be 3, and always put it in parentheses. So I'm just taking the x away and putting in its place a negative 2. Okay, I do exponents first. So negative 2 times negative 2 is 4. 4 times 3, that's going to turn to a 12. This is a negative 24 and a negative 6. So 12 and a minus 24 is a minus 12. Minus 12 and a minus 6 is a minus 18. So my vertex is going to be left 2 and down 18. Okay, they give you a function in standard form and they want you to graph it by changing it into vertex form. So vertex form is y equals ax minus h squared plus k. Okay, completing the square. So here's what we're going to do. Y equals x squared minus 4x. I'm going to take this plus 6 and just scoot it over here. So if I try to complete the square, here's what I'm going to do. I'm going to take this middle number right here, negative 4. And I want to know, if I get rid of that 6, if I scoot the 6 over and I replace it with the number of my choice, what number would I choose that would make this a perfect square? And it all depends on this middle number. So you get the middle by addition. So I get this negative 4 by adding two numbers. I'm going to take some number and add to get negative 4, and I want it to be the same number because that's the definition of a perfect square. So I want this to be a negative 2 and a negative 2. Okay, now if I add a negative 2 and negative 2, I get negative 4. But if I multiply them, I get a positive 4. So I want right here, I don't want the 6 they gave me. I want there to be a 4 here. So you just take this b, you cut it in half, and then you square that number. So if this were 6, I would cut that in half and it would be a 3 and a 3. And then this would be 9 because 3 times 3 is 9. Okay, now, if I add 4, the very moment that I add 4, I've got to take it right away. Or else I have jeopardized the whole equation. So if I'm going to add 4, I got to take it right away. Okay, now these guys right here combine and give you 2. But this, if I factor this, this is the exact same thing as x minus 2 and x minus 2. And I can rewrite that as x minus 2 squared plus 2. Okay, now this is going to be a piece of cake. So without much stress, you can change that into vertex form. Okay, now if it's in vertex form, this is going to tell you to go right to, this tells you to go up to. So go right to, up to, graph your vertex. I just need one more dot. So here's what I've got so far. X, Y, I've got over to, up to. So I'm going to try a dot close to this. I'm going to try 3. I'm going to try going over 3 times. So if I take 3 and I want to know what the Y is, you just take it and you plug it into the model. Do the math. So 3 take away 2, that's 1. 1 squared is 1. 1 plus 2 is 3. So it's going to be over 3, up 3. There's a dot there. That dot's for free because it reflects across my line of symmetry. And there is my graph. Okay. Change into factored form. So factored form, I want to factor this. I want to take and use this little template and ask yourself what's going to multiply and give you the end, the c. It's got to times and give you c, but it's got to add and give you b. And it is going to be a -4 and a -1. So you can rewrite this in standard form as y equals x minus 4 and x plus, or not plus 1, x plus a -1. So now you just change it to factored form, which is the model we're after now. When it's in factored form, it's really easy to get the zeros. I want to know what I plug in for x that's going to give me 0. So you can plug in 4 and 1. Because when I plug in 4 for x, 4 take away 4 is 0, 0 times that is 0. So now these 2 dots I get for free. These are my roots, these are my vertex. So 4 and 0, 1 and 0. Okay. I just need the vertex, and I know the vertex has to be halfway between them. So this dot and this dot, I take them, 1 and 4, and I add them, and that gives me 5. I'm just taking the average of those 2 dots. So I'm going to cut 5 in half. 5 divided by 2 is 2.5. So 2.5 right here, I know my vertex is on that line. So I'm going to do the same thing we've done in every single problem almost. I'm going to take the 2.5 that I know for x, and I'm going to plug it in here. I'm going to plug it in here, do the math, and that will tell me the y. So if I do 2.5 minus 4 times 2.5 minus 1, just do it on the calculator. I get a -2.25. So now I'm going to go over 2.5 and then down -2.25. So somewhere like right there. And you're done. Okay, factor these. I'm just going to go through the evens, because the odds are just the exact same. So number 2, okay, 2 and 4 you can do, they're pretty easy. Use the template. I look right here, and if I see that that's a 1, I'm pretty pleased, because those are usually pretty easy. So you times and get 63, add and get -16, and and I'm not sure, so I'm going to make a list of 63. 1 and 63, and then I do a calculator. 63 divide 3, and I know that's going to work. Is that 21? So 3 and 21 is a pair. 63 divide 4, probably not. 5, no. 6, no. 7, yeah, 7 and 9, and that's it. 7 and 9 is what I'm after. So it's going to be a -7 and a -9, because added together they give you -16, times together they give you +63. So your answer to 2 is just x minus 7, or n minus 7, and n. I guess I should stick with both x's or both n's. N minus 9. Okay, but look at let's look at 6. See, so I think they're going to get harder and harder and harder as we go down. 6, 4p squared minus 1. Okay, this one, gosh, I won't give it to you because we haven't done it, but let's do this. P squared minus 1. I'll give you this. This one's fair. So p squared minus 1. 4p squared minus 1 is not too fair because we haven't done any. But they've got to times and give you a -1, but it has to add and give you 0. So p squared plus 0p minus 1. The middle is missing. It's not there. I've got the p squared and I've got the constant, the number, but I do not have any p's in the middle, so that's 0. So it multiplies, gives you the end, adds and gives you the middle, and it has to be 1 and a -1. That multiplies and gives you the top, adds and gives you the bottom. So my answer is p minus 1, p plus 1. Okay, now let's look at 8. 8. This is kind of starting to get ugly because that is not 1, that's a 9. So let's look at these other two. And 9 and 30 and 25, you notice they're all divisible by anything. That's what we're looking. We're hoping we can divide them all by something. Divide them all by 3, no, 5, 2. So it looks like it's going to be kind of a beastly problem. Okay, this one I'm not going to give you either because we haven't done any of them, but here's what you want to notice. If you look at that 9 and that 25, they're both perfect squares, and anytime you've got both of these being perfect squares, you're kind of suspicious. So let's try this. Let's try taking the square roots of both of them. Let's go 3x plus 5 and 3x plus 5, and if I multiply through, that's going to be my 9x squared, and this is going to be my 15x, and this is 15x, and this is 25. So that actually worked. 9x squared plus 30x plus 25, but it's not going to be on the test because we haven't done any. But I want to get into 12. Let's talk about 12. So look, on 8, they got nothing in common, but if you stare at the first and the last, they're perfect squares, so it's kind of a unique problem. Let's look at 12. 12, these guys, do they have anything in common? They don't, and this is not a perfect square, and this is not a perfect square. 12, this is going to be on the test. So here's the trick for 12. If a is greater than 1 and there is no GCF, I'm going to take 3 and I'm going to multiply it by -18. So I take my first and my last and I times them together. So 3 times -18, -18 times 3, that's going to be -54. Okay, now I'm going to use this little template, and I'm going to try and find something that multiplies and gives you -54 but adds and gives you 25. Okay, so 54. Maybe let's go through the list. My options are 1 and 54. 54 cut in half is 27. Okay, I'm going to stop there because I think I can make it work with the 227. So it's got a times give you negative 54. So I know my 2's got to be negative. So positive times negative is negative. 27 minus 2 is 25. So that works. Now I'm going to take this 25. So I'm going to copy and paste 3x squared. And I'm going to rewrite the 25 as 27x and a minus 2x. And then minus 18. Alright, so we have taken a problem with 3 terms and we broke up the middle. We got to replace it with something that equals 25, and I know that 27 minus 2 is 25, so I'm legal. So far I haven't done anything that changes it. So you take the first times the last, see if you can factor it. Okay, now I'm going to group them. I'm going to group these two together, and I'm going to group these two together. So what do these have in common? Divide them both by 3x. So 3x times x plus 9. What do these have in common? Divide them both by negative 2. So that's going to be x plus 9. Okay, now what does this group have in common with this group? And that is the x plus 9. And in the other group, it's going to be 3x minus 2. And that is your answer. So if a is bigger than 1, and there's no common factor, this is the method that we use. Okay, last one, let's look at maybe something like 10. If you've got r squared plus r, they both have something in common. Divide them both by r. So 10 looks like that. 9 looks like that too. Solve the equations. Okay, 16 and 18. Let's do 16 and 18. Move number 1. Get everything on the same side. So I'm going to bring this over. I'm going to plus v. And there's no v here to add it to. So I've got v squared plus v minus 2 equals 4. Minus 4 minus 4. V squared plus v minus 6 equals 0. Okay, 0 is what we like. Get everything on one side, so you got a 0. Now, I like this because it's 1. A is 1. If A is 1, I'm going to try and factor it. So does there exist two numbers that multiply and give you a negative 6, add and give you 1? And it's going to be a 3 and a 2, and 1 must be negative because they got a times give you negative. So I'm going to go with the 2 negative because 3 minus 2 is 1. So we're going to change it to v minus 2 times v plus 3 equals 0. And then what must v be for this to be true? V must be a 2 or a minus 3.